Good morning, students. You are welcome into this platform of learning. Last time we ended with reflection and the refraction. You can vividly revise what we did. We can therefore define refraction as the bending of light when you move from one medium to another of different optical density. And therefore, when light moves from one medium to another, the wavelength of the wave or the wavelength of the light wave reduces, the speed reduces, but the frequency remains the same. We equally define reflection as a bouncing back of light when you come across an obstacle. Okay, today we are going to look at some effects of refraction. And on the board here, we have two effects that we are going to see. We have the real and the apparent depth, and we equally have mirage. What is real? Something is real, and something is apparent. From these two words, you can distinguish what is all about real. Something is real depth of a point. For example, if you take a coin and you drop in a pool of water and you stand beside the pool of water, it seems the coin is right on the surface. But if you dip your hand to remove the coin, your hand will keep on going down, down, and down. This effect is known as the real depth and apparent depth. That is why in most cases, it's not advisable to go to a swimming pool and just dive into the swimming pool without knowing, because you are not even a physics student. But today you are going to know it, and you should be able to apply what we are going to learn today. Therefore, when you talk about real depth and apparent depth, we look on the bottom, we're looking into a pool. Its bottom appears shallower. It means that its bottom is almost closer to the surface. Its bottom appears shallower. The bottom is closer to the surface of that pool than it actually is. Okay. Equally, we have another phenomenon, which is when you dip a stick. If you have a stick, you dip in a pool, and you look into the pool, it seems as if the stick is bent. This effect is known as refraction. These are effects that we see every day. This is because light is moving from optically less dense medium to optically more dense medium. We go to the second point here where we have mirage. It is very common, especially in the dry season, when you are moving on a tarred road on a very hot day, and you stand at a distance, you look at the distance ahead of you. It seems there's a pool of water on the tarred road. But as you move closer to that point, nothing. You can't see anything. This effect is known as mirage. This is because the solar rays are moving from the colder part of the atmosphere and coming down to the warmer part of the atmosphere. As a result of that, the rays are bound to bend, producing what is known as mirage. That's why we see the surface of the tarred road as if there's water on the surface, which is not like that. Okay, here we have total internal reflection. What is total internal reflection? Something is total internal reflected. It means that it goes and comes back. Light rays are also total internally reflected. More especially when light moves from a more dense to a less dense medium, the light rays is bound to go and return back to its original medium. This is very applicable. This total internal reflection is applicable in optical fiber because optical fiber function on the basis of total internal reflection such that none of its energy should be lost along the way when information is being transmitted from one point to another. Okay, dear students, we equally have activity that I'm going to present to you that is presented on the board already. With this activity, I believe you are going to draw a diagram because this information is going to be accompanied with notes. If you look on the board, you will see draw a ray diagram to show how a stick appears when partially immersed in water. This diagram is in a notebook, but I expect you to give a detailed explanation of the diagram. Thank you very much. I will see you in our next lesson.